Lesson 9.5, Quadratic Formula. The objective today is to solve quadratic equations using the quadratic formula. We have looked at quadratic equations for quite a while now, and we have solved them in a variety of ways. We started by learning how to factor them and set each factor equal to 0. That's the first way. We looked at graphing and how where the parabola crosses the x-axis, that would be a solution. We completed the square, and we also did perfect squares and square rooting to solve. Now, this formula will work with every quadratic equation. If you ever are unsure which way to do it, you can always rely on this one. It's going to give you the answer. I highly recommend, when you're just giving a quadratic equation and they say solve it, I highly recommend trying to factor it first, because that's probably the quickest way. But this is a guaranteed, surefire way of getting an answer. This is used for those that don't factor, and their answers are probably going to come out as decimals. Okay, so quadratic formula is something universally known, something that you will use for years to come. So let's review about A, B, and C. So a quadratic equation is always in the form ax squared plus bx plus c equals 0. We've already talked about how you should be able to recognize A, B, and C, and that's even more important with this lesson. To solve by using quadratic formula, you use this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, you see this part right here, plus or minus? That's how you get two answers. You've got to consider doing the positive of what's in the square root and the negative of it. Because of that plus or minus, you can figure out by the discriminant how many answers you're going to have. Okay, what's the discriminant? The discriminant is the part under the radical sign, b squared minus 4ac. Okay, if you look at b squared minus 4ac and it is a positive value, when you take the square root of a positive value, don't you get two solutions? If you had the square root of 9, wouldn't you have 3 and negative 3? So if the discriminant is a positive value, you would have two solutions. And the parabola would cross the x-axis in two spots, just like that. If the discriminant, what's inside the radical sign, if it is negative. Well, can you take the square root of a negative right now? No, we can't do that yet. So there are what's called 0 real solutions. That's what we're interested in algebra. And it just means that the parabola is like this one. It doesn't even cross the x-axis. Okay, so that if it's negative, you can kind of stop and say you don't have any real solutions. And then finally, if it turns out that it is exactly 0, what's the square root of 0? 0. So then there wouldn't be two answers, there would just be one. It would be this, and then this would be gone because that'd be 0. So this over 2a. And if that happened, it would be the circumstance where the parabola just touched the x-axis with its vertex. So that discriminant can tell you a lot about how many answers there are. So first of all, before we actually do the whole formula, let's look at this and study the discriminant a little bit. it says state the discriminant, then determine the number of real solutions. So I have this example, x squared plus 4x plus 3 equals 0. Always make sure it's equal to 0. If it's not, bring whatever's there over so it is equal to 0. I want to find A, B, and C. So my A would be 1, B would be 4, and C would be 3. My discriminant is B squared minus 4AC. It's the part that's under the radical sign. So we're talking 4 squared minus 4 times 1 times 3. I'm just plugging numbers in. 4 squared is 16 minus 12. The answer is 4. So it came out positive. So I would say 2 real solutions. Now we haven't solved it. We're just saying when you do solve it, there's going to be 2 answers. So the discriminant is a pretty important part of this. It tells you how many answers you're going to have. You may or may not have to define this discriminant just for the number of solutions. It depends on what the directions say on particular problems. Yeah. So on problems like this where it says state the discriminant, you go through and you solve this, and my discriminant is 4, and then you can state, since it's a positive, then you would say that it has 2 real solutions. If that came out to 0, you'd say 1 real solution. If it came out to a negative, you'd say 0 real solutions. Yes?
If it's 0, you don't have to go.
If it's 0, then you don't have to go any further. No. This isn't actually solving the quadratics yet. This is just a way to tell if you just need to know how many solutions there are. Okay? We're not really solving it just yet. All right, anything else about the discriminant? So now, oh, they want us to do another one. Doggone it. Here we are. 2x squared minus 4x plus 10 equals 0. So my A is 2, my B is negative 4, and my C is 10. So B squared minus 4AC is my discriminant. So negative 4 squared minus 4 times 2 times 10. Negative 4 squared is 16 minus 80. It would be negative 64, and you would say 0 real solutions.
Would you, like, if you're going to equate?
Now we are actually going to solve using the quadratic formula. So x squared plus 6x plus 3 equals 0. So it's already equal to 0, so we're good to go. A is 1, B is 6, and C is 3. X equals, and when I go through, I just start plugging in. So negative B would be negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 3 all over 2 times 1. So negative 6 plus or minus the square root of 36 minus 12 all over 2. Okay, and negative 6 plus or minus the square root of 24 over 2. Okay, and we haven't learned simplification of radicals yet. That is coming up, but at this point then what you would do is use your calculator, and you would do negative 6 plus the square root of 24 and get an answer and divide by 2. When I do that, I get negative 0.55, so I'm going to round it off to negative 0.6. And so I would do negative 6 minus the square root of 24 and get an answer and divide by 2. And I get negative 5.44, so I would say negative 5.4. I'd round to the nearest tenth. So right now we're going to use decimal answers. So you're rounding to the nearest tenth. Okay, I'm going to go double check to make sure it's tenth and make sure it's not hundred. All right, next example, 3x squared minus 7x minus 6 equals 0. So again, it's good because it's equal to 0. If it would not be equal to 0, you'd need to bring everything over to one side so that it was equal to 0. My A, B, and C. A is 3, B is negative 7, and C is negative 6. X equals, okay, negative B, so B is already negative 7. So negative 7 would just be positive 7 plus or minus the square root of, and I'm going to put negative 7 squared minus 4 times 3 times negative 6. And that is all over 2 times 3. So 7 plus or minus the square root of 49. And then if I look at this, it's negative 4 times 3 times 6. 4 times 3 times 6 should be 72. So plus 72 all over 6. So 7 plus or minus the square root of 72 plus 49. Oh, nice. 121 over 6. And last time I checked, square root of 121 is 11. Oh, those are nice. So I would do this now. 7 plus 11 is 18. 18 divided by 6 is 3. That's one answer. 7 minus 11 is negative 4. Negative 4/6. Do you know what? I'm going to go negative 2/3. Why would I mess with the calculator at that point? Negative 2/3 is easier. So those are nice. If it comes out to be a really pretty number in that radical sign, you're good to go. Remember, if it comes out to a negative in the radical sign, you can immediately say that there's no solution. If it comes out to 0, then you would just put whatever negative b over 2a is would be your one answer. And then some of the problems are going to ask just to find the discriminant and how many solutions there are.